Hello and welcome. In this video, we're going to take another look at our P6 practice, and specifically, we are going to focus on the version of our P6 practice that allows for us to import a CSV file for the purposes of searching or adding or removing or updating an inventory. Now, ultimately, we are going to be reading in this CSV file, putting it into an array of structures. And then in this particular video, we are going to focus on how to search that array of structures for a match of a value for a given field name. The idea here is using this function search structs by string exact. We are going to search our structure array for the field name and the exact match for the value in that field name, and we ultimately will return the index of the row or the element in that array that has the exact match. The last thing to note out here is that the by reference M integer tells us how many matches we have found in our array. Now, to understand what we're going to try to do, we want to take a look at our products.csv. The first column is the ID, the second column is the name, third is the type, fourth is description, fifth is the price, and sixth is the quantity. We are going to be focusing in on the ID, the name, and the type, and we're going to leave the others for later videos. The idea is that I want to be able to pass an ID, for instance, my ID 005, and I want to get back the information associated with that particular item or product. I can also pass, for instance, the name of the product, maybe focusing on Pepsi, or I can focus on the type. You'll notice that if I focus on the type, then I could potentially get back multiple elements or multiple rows in this cell array or in this CSV file. Now, let's go ahead and get started real quick. We're going to, again, focus solely on the search structs by string exact function. And to start off with, what we want to do is we want to check to see if each of our input arguments are in fact valid. And so to begin with, we want to check to see if our search structs is equal to null. And if it is, it simply means that somehow a null value was passed to our function. We want to provide an error back to the user using a printf. Please provide a valid search structs, in other words, a valid array of structures to search. Follow that up by results are equal to exit failure. And again, since we've done this now a couple of times, I'm going to go ahead and do a little bit of copying and pasting here for the additional arguments. The field name needs to also not be equal to null, as well as needing to be greater than 0 in length. So we're going to have an else if and a compound condition here, in that our field name can't be equal to null, and or that the field name, the string length of our field name, is equal to 0. If either of those conditions are true, then please provide a valid field name. Otherwise, our results will be equal to exit failure. Continuing on with this theme here, we want to check to see if our exact match is equal to null. And if it is, again, message to the user letting them know there's a problem. Please provide a valid exact match. Our last condition that we want to check this way is going to be that our indices are equal to null. And if they are, please provide a valid indices array. Otherwise, under the else, we can start checking to see that our field name is in fact valid. Now, there's a couple of ways that we can go about doing this. We could have included this in the original else, if, else, if, else, if triaging. However, we're going to start doing this. We're going to do this one just a little bit differently, because if we do it in a nested if statement, we can actually then start searching the individual fields in the array of structures. And you'll see in just a second why I am breaking this up into a nested if statement. And so the other thing that you want to go ahead and set up, if you haven't already, is you want to go ahead and have a search index associated with the search structs. Made a little note to myself here to call it search index, just to make sure that we differentiate it from the indices. The idea is that I need to be able to keep track of where I am inside of my for loop that loops through the search structs. But before we get to that, then we can simply start off with another if statement. And the idea here is that if my string compare I matches my field name to one of the valid fields in my structure, so in this case, it's going to be ID. In other words, if that was what was provided to us or what was passed to us, and if that matches, well, the idea is then I will loop through or look at my ID fields. Well, if using an else if and a string compare I, if my field name matches the name field, then what I will do is I will look at my dot name fields. If using an else if, and again, the string compare I against my field name, and if it matches the type, well, that simply means that we are going to be looking at our type field. And then lastly, if we've managed to make it this far, in other words, we haven't found a match with the field name, that's under our else. We again have a print statement, printf, error, please provide a valid field name that is in the structure. In other words, this is our way then of refining our error message, and nonetheless, our results will now be equal to exit failure. Now, we will have a little bit of redundant code in this particular project. There are ways of getting around that using addresses in the structure itself and the order of the fields in the structure. Basically, we can play some memory management tricks, but for this example, I'm going to keep this one pretty straightforward in that we simply want to now loop through each of the elements in our structure using our search index. Rather, be clear here, we want to loop through each of the structures in our array using our search index, starting at 0, and we want to continue. The search index is less than n because n is the total number of structures in our array of structures. And then lastly, we want to increment our search index by using the plus plus. And then what we can do is, again, simply using our string compare I. So if string compare I, utilizing our search structs and the search index, compare the field that we wish to compare, which in this case, since we have passed ID, will be the ID, and compare it to whatever the exact match was. I want to compare it to the exact match. And if that is equal to 0, we have found a match for the field name and field value, meaning that we have found the ID the user was looking for. Now, in the ID scenario, there will likely only be one ID. The intention is the ID is supposed to be unique. However, though, we cannot assume that. And so what we're going to do then is we're going to store in the indices array, utilizing the M that we have passed by address. We are simply going to store whatever search index for the structure in the array of structures that matched. And the only thing that we need to do that we've not yet done to make sure that this works is that simply in our else, or at some point in our code, we need to remember to initialize our M to 0. And then whenever we find a match, we simply increment our M. Now, under the else branch, technically there really isn't anything to do because we are using a for loop. So in other words, we are going to keep on looking until we run out of structures to look at. And at this point, you can probably guess that the only difference between the for loops that we're going to be leveraging here will be which field we will be looking at. And so what we can do is very carefully copy our for loops into our other branches of code, changing only the field name to match the one that we wish to look at. And again, this works because we're doing essentially the same process. The only difference is we are changing which field we will be looking at. So the name field for the second option, the type for the third. And again, there are ways that we can get around doing this, and we can actually consolidate this code even further. But at this point, let's take a second to make sure that we understand what is going on. The idea is that I specify that I want to look at the field name. That's the purpose of this string compare I. And if I do want to look at the field name ID, then I start looping through the array of structures, simply checking the ID over and over again based on the exact match, or rather comparing it to the exact match. And if I have found a match, then I simply store it in my indices. I increment how many matches I have found, and then I just simply keep looking. Now, again, with the ID, it's assumed that it might be unique, but with the name, and definitely not with the type, those assumptions cannot be made. And specifically with the type, if you go back to the CSV file, you'll see that there are multiple drinks. And what we can do then is we can compare the type, and we can just simply keep track of how many indices we have in fact matched. Now, the only comment that I have to make about this code is that we technically also need to check to see that the value of M does not exceed the number of elements in the indices array. This is rather trivial for this particular example because we're assuming that we've got statically declared arrays. We are actually not going to worry about that. We're just going to assume that the n max is the same for both the search structs as well as the indices. In other words, I've got way too much room in my index array or my indices array. And that more importantly, I can't have more matches than I do structures in my array. Otherwise, when you start dealing with dynamic memory allocation, you would actually want to grow this particular array as we started adding entities or entries in it. At this point, we should be pretty much ready to test our function. And so let's go ahead and build it to see if we have any typos. Nope, everything looks fine. We are, in fact, returning our results. We are updating our M. Hopefully, we're also updating our indices correctly and that we have no typos with discerning the field name and the exact match. Now, easiest way to test this is to, again, come up to our main and work with the essentially the stub for our if statement here that was already dealing with the search and the ID. Again, we'll leave more extensive testing to a later video, but what I want to do is I want to read in the products.csv. I want to update the products array, keeping track of the number of elements I've read. I then want to just simply display it. And then at this point, then what I'd like to do is I'd like to search by string exact. And what I will do is I will pass my products cell array, or rather not cell array, sorry, structure array. I will specify the field name. In this case, I'm going to go ahead and put in ID. Why do I put in ID? Well, that was what was passed by the user. In other words, that's how I would have gotten to this particular branch. I'm going to pass my argv square brackets 2 because the argument 2, or rather the argument 3, would have been what was passed by the user as the fourth argument to our executable. I need to create an indices array. I can pass my n, and I also need to pass the address of an m variable, which is also an integer. Now let's go ahead and create these additional 2 variables up here, specifically my int m, and then also my int indices, which again, we're going to make it far too large by simply specifying our n max, and our m will be used to keep track of the actual use of the indices. And at this point, then what we need to do is we need to go ahead and loop through, once this function returns, the indices to discover which one of our products matched the conditions. The easiest way to go about doing this is then to set up a for loop. And again, what we'll do is we'll use our index variable that we had set up earlier. So for index equals to 0, index less than m, because m is going to tell us how many matches there were, and then index plus plus. And then what we can do is we can again use our display product singular function, and we can simply specify using the products, and we're going to use the square brackets of our indices. And then this is going to look a little strange here. Again, a second set of square brackets and the index. And so what we're really doing here is we are accessing the value in the index, or using the value in the indices, which is also an int, to access the appropriate structure in the array. Now, I seem to have an error here. Let's see if we can figure out where it is. It was just trying to keep up with me here. All right, so at this point, then we probably have a little too much noise. I tell you what, why don't we take just a second? Let's run it and we'll see. Perhaps we won't have any problems here. The idea is that I want to pass now, instead of ID something, why don't we actually pick a valid ID? In other words, I would like to return ID 004. If I pass this, then hit enter, and you can see here, sure enough, I have in fact actually returned my Jumex. And if anything, what we can do is, why don't we just temporarily turn off the display products, because we're convinced that portion works. And then let me run this one more time. And you can see here that there, of course, is my noise for my import, which we can also take a second to turn off. You can turn it back on if you have any issues with troubleshooting, but this particular line doesn't mean as much to us now. And there we go. You can see that passing ID 004 gets me Jumex, ID 005 gets me Oreos, ID 006, bananas. And then if I put in something that doesn't exist, I get nothing. Now, at this point, we've got two things left to do. The first thing that we need to do is we need to go ahead and figure out how to get those results into an array that can ultimately be exported to our CSV file. And essentially what we're going to do is we are going to leverage now our products array, and we need to create another array that we are going to call results. And in this case, we've already got a results variable. So why don't we take just a second to create now a product properties. And we'll call this results or product results underscore product. And again, we're going to make this way too big. Okay, if anything, because we are still dealing with not being able to use dynamic memory allocation, this is going to be far too large. Okay, ultimately, we need to redo this with our malloc and our realloc. But at this point, then what we can do is we can simply copy from the products to the results products the corresponding structure that matches wherever it was found utilizing our indices. And so the idea here is we can display it, of course, but we can also copy product. And remember that the first one is the source. So in this case, we're going to call this our products. And we can again use our indices, square brackets index, and then for the destination is going to be the results products. And we are going to leverage then our index variable. I have a mismatched square braces there. Give me 1 second, put that back over where it belongs. And then what we're going to do is we're essentially going to use whatever value is in that index array or indices array that will identify which product needs to be copied over to the results product. And remember that the idea here is that this index leverages M, which leverages then the number of matches we found using our indices array. At this point, then we can actually just simply pass our results products to our export products function. And in this case, we're just simply going to call it results.csv, much like we did earlier. And we specify how many there are. Well, in this case, there is only M. Now I'm going to go ahead and comment out this export products because we don't want to overwrite our results. But if we build this now, actually, 1 second here, we have a typo. Let's see if we can get this right here. Yes. We need to pass these by address. Our copy product uses addresses. There we go. Much better. And now what we can do is we can come over here to our command window, type in dir. I'm going to go ahead and delete my results just so that you guys don't think there's any tricks going on, notice my results are now gone. And what I'd like to do is I'd like to simply get my Jumex file, or rather my Jumex product, into my results.csv. And if you drag and drop, you'll see that my Jumex is now in a separate file by itself. I can change this to ID 005. Here's my Oreos, 006, bananas. And then again, if I put in something that doesn't already exist, you can see that it is not, in fact, going to overwrite that file. Now, we can change that behavior a little bit. In other words, if the ID does not actually exist, then what we can do is we can still overwrite the results file. As a matter of fact, one of the first things that we can do is actually delete the results file. But for right now, we're going to leave that behavior the way it is. We can come back and revisit that. I see what happened here. Hold on one second. We need to push this outside of the for loop. There we go. Let's try that one more time. There we go. All right, much better. That didn't make any sense when it happened, and I didn't realize what was going on there. So you can consider this a live mistake here. All right. So anyway, the export products needs to come outside of the for loop, because that's essentially how we're going to build the results products. And then once we've built the entire results products is then when we're going to export it. Now, I'm going to stop this video here, because I want you to go back and finish this for the name and for the type. But as always, if you have any questions, comments, or concerns, don't hesitate to reach out to me. And thank you for watching.